Okay, today we're going to look at what happens when you get negative exponents, things like this, x to the power of negative 3, or just in general, what does a negative exponent mean? I'm going to start by doing an example. So let's say 2 to the power of 5. 2 times 2 times 2 times 2 times 2. 5 2's multiplied together makes 32. What happens if I start working this exponent down? So we get 2 to the power of 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. I'm just multiplying it out. Okay, what's 2 to the power of 3? 2 times 2 times 2. What's 2 to the power of 2? 2 times 2 is 4. What's 2 to the power of 1? Well, it's just 1, 2. And now here I have to ask a question. What's 2 to the power of 0? Well, let's stop and look. Is it 0? I've been going down with the exponents here. Look at what I've been doing over here on the left, though. To go from 32 to 16, and from 16 to 8, and 8 to 4, and 4 to 2. What am I doing every single time in this column? Like, how can I go from 8 to 4 and 4 to 2? It's the same operation. On the left-hand side here, every time I'm dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So I'm going to guess then that if I keep following this, I'll get the next one. What's 2 divided by 2? 2 divided by 2 is 1. So 2 to the power of 0 is 1. It's not 0. It's actually 1. It's a weird trip, huh? So remember, this is saying it's a shortcut for multiplying. Well, if you're not multiplying anything, you must have started with 1. Because 1 times then whatever you have will turn into whatever you have. So this is 1. This leads to our first point. Anything to the power of 0 is 1. So if I was to write that mathematically, x to the power of 0, doesn't matter what x is. It could be 1,000,006,000, but if it's to the power of 0, it equals 1. Again, if you need to write all that down, pause it, and we'll keep going. Now what's going to happen next? Well, look at over here on the left. I got 5, 4, 3, 2, 1, 0. What comes next? After 0, it's negative 1, and then it'll be negative 2, and then negative 3. All right, my exponent. I'm just counting down. Well, after 0 comes negative 1, then negative 2, and then negative 3, and we'll stop there. What are these going to equal? I don't know. Let's keep filling in this pattern. I started with 32 divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. Okay, let's divide by 2 again. What's 1 divided by 2? We could write a decimal, but I don't want to work out. 1 divided by 2 is 1 divided by 2, a half. So 2 to the negative 1 is 1/2, or 1 over 2. Divided by 2 again. What's half of a half? 1/4. And then continue. If I divide that in half, a half of a 1/4 is 1/8. So what happened here when the exponent was negative? Well, one, it started out, it made a fraction. But how did you get these numbers underneath? Well, let's look over here. Look at 2 to the power of 3. 2 to the power of 3 was 8. 2 times 2 times 2. 2 to the power of negative 3. That was 1 over 8. So it's 1 over 2 times 2 times 2. Check out 2 to the power negative 2 and 2 to the power 2. 2 to the power 2 is 4. 2 times 2. 2 to the negative 2 is 1 over 4. Compare the one and the other one. 2 to the power 1 is 2. 2 to the power negative 1 is 1 over 2. Can you figure out what the general rule is when it's a negative exponent? Well, a negative exponent, positive ones are, the technical way is it's exponents are a shortcut of multiplying. Well, when it's a negative, it's like the opposite of multiplying, so it's dividing. It's a shortcut for saying repeated division. But for us, what does it look like? For a negative exponent, all we're going to do is make the answer a fraction. We're going to make it a fraction. Because you look at 2 to the power of 8, or sorry, 2 to the power of negative 3, it's the same as 2 to the power of 3. It's just the fraction of it. It's not 8, it's 1 over 8. It's still 2 times 2 times 2, you just put it on the bottom of the fraction. So let's see what this looks like in an example. If you need that, go back and rewind this. 8 to the power of negative 2. Well, to get rid of the negative, you just make it on the bottom of a fraction. And then we can figure out what 8 to the power of 2 is. 8 to the power of 2 is just 1 over 64. Okay, try again. Like 3 to the negative 3. Well, the negative just means it's on the bottom of a fraction. And you figure that out. 3 times 3 times 3 is 27. This also comes in when we did division. We subtracted from the biggest minus the smallest. But in general, you could always do the top minus the bottom, numerator minus the denominator. All right, x to the power of 2 minus the power of 5 would be x to the power of negative 3. So what does this mean when you get a negative exponent if you were subtracting? The negative exponent just means that your answer goes on the bottom of the fraction. Or maybe I should say it goes to the other place. Because my last example here, what if the negative was already on the bottom of a fraction? If it's already on the bottom, then it flips to the other place. It's like dividing, which would be multiplying. Or flipping and multiplying. So if it's already on the bottom of a fraction, to get rid of the negative sign, you put it on the top of a fraction. So recapping, a negative exponent, like 8 to the negative 2, just means that it's 8 to the power of 2 on the bottom of a fraction. The negative is a shortcut of saying it's a fraction, or it's dividing. It's all the negative means is it's a fraction. And you could still figure out it's still 3 to the power of 3, which is 27. The negative just means it's on the bottom of a fraction. When you subtract, it's okay if you get a negative, because that just means your answer goes on the bottom of the fraction. And if your answer is already on the bottom of a fraction, and it's negative, that just means flip it to the other side. Put it on the top of the fraction, the numerator. Get x to the power 2.